We is being used loosely. I am going to be doing the experiment because I am doing it. You're all not. You're going to be watching the experiment. You're going to be making predictions. You're going to watch the experiment, and then you're going to be drawing conclusions from the experiment itself. Okay? Now, when we do experiments, one of the things you have to think about is, as a scientist, scientists are constantly making predictions. What's a prediction? What's a prediction? Can be an idea. It's more than just an idea, though. What's a prediction?
Opinion?
More than an opinion.
Thinking what will happen ahead.
Thinking ahead of what will happen, yes. What do you think will happen? Now, it's not just a willy-nilly thought, what you think will happen, but based on things that you already know to be true, what do you think will happen in this certain situation? Okay? So when we think about those kinds of things, you make a prediction. What do you think will happen? Then you run the experiment, and based on the things that you saw in the experiment and the data that you have recorded, what did actually happen? And then you go back and you compare it to your prediction. Was your prediction true or false? Okay? What evidence do you now have to back it up? Okay? What things do you need to change? What thinking do you need to change? Okay? Are there things that you need to adjust in your thinking? Okay? Are there things that you need to rethink the next time you run across a situation? So, are there predictions that you need to think about, like the next time a situation comes up? When you do this experiment, the next time you do another experiment, are you going to think differently about your predictions? So a lot of scientists make predictions ahead of time. This is what I predict will happen. So in the wintertime, when winter's coming up, a lot of times we make predictions on how much snow we're going to have. Okay? Well, what are our predictions based on?
The snow, like the weather.
Okay. What else might our predictions be based on? If what?
If it's going to
Okay. What else might our predictions be based on? Okay. What else might our predictions be based on? How do we know how much snow we're going to get? Because that's what our results will be based on.
How big the clouds are.
Okay. What else might our predictions be based on? Okay. But our prediction is what we think will happen in the future. In the future. So what might our predictions be based on? Anybody at home have any ideas? What might our predictions of how much snow we have this winter be based on? But it hasn't been winter yet. If we're predicting how much snow we'll have this winter, do we know what our weather is yet this winter? So what might our predictions be for how much snow we'll have this winter?
Like if the sun's on our side, that, no,
Let me help you with this. Could our prediction for how much snow we have in Indiana be different than our prediction for how much snow we have in Florida?
Yeah.
Why? Why? Why would those two predictions be different?
Because the equator is more the axis of the earth.
True? True?
Because of snow in Florida.
Huh?
If you go down with snow in Florida.
Okay.
Because in Florida, it's usually warmer because it's not equator.
So we are basing our predictions on what?
The equator.
No?
How did I say in Florida?
Yes, but what are we basing our predictions on? What we already know has happened in the past. So we're basing our predictions on things we already know from the past. What is normal? What has happened in the past? And typically we don't base our predictions on one thing that's happened in the past. We base it on a series of things that has happened in the past. We don't base our predictions on one occurrence. Okay? Have you been around when it snowed a lot in the past in Indiana? When there's been a lot of snow, and we had to stay home a lot from school because it snowed a lot. Have you been around in Indiana when it didn't hardly snow at all, and we never had hardly any snow days? Okay, so in those two different years, you might have had different predictions if you only looked at each of those years individually. Does that make sense? So if you lived in Indiana, the year it snowed a lot, your prediction for the next year might be, it's going to snow a lot in Indiana, right? But if you only looked at the year it didn't snow much at all, your prediction of how much it would snow in Indiana might be, Indiana doesn't have much snow at all. But we look at a series of events before we make a prediction. If we have that opportunity, we look at a series of events and we make a determination on that. Does that make sense?
Yeah.
Okay? Today, though, some of our predictions we don't have a lot of background in, okay, of that particular item, but we use what we do have as our own backgrounds to make predictions, okay? All right? So with that in mind, I keep getting people wanting in. With that in mind, we're going to start our lesson, and those of you at home, you should go into Google Classroom and find a worksheet on mass and volume. Those of you in class here, I have a copy of it, and I will be passing that. I'm sorry. Please get your name on this paper. Make sure you have your name on your paper. Yes.
What's the date?
Today is September 1st.
9+1+22.
Yesterday we looked up, or we wrote down a definition for volume. Let's look in our notes and see what our definition was for volume. Those of you at home should also have it. So you should be looking in your science notes what our definition was for volume.
Is it the one with the blended water?
Anybody from home have a definition for volume? Anybody from home have a definition for volume? All right, how about from here? What about the answer for volume? 20. Okay. What are you doing?
Somehow he grabbed his stuff out of his thing, but he got.
Okay, you should be writing.
Yeah, this ain't mine. Nobody does it in my face. It's, there's a bonus to number 5.
Okay. Those were just randomly handed out. We didn't match them up with anything. Mass. Mass. Look at what mass is. We know what mass is. Winnie.
Anything that has weight that takes up space.
Anything that has weight that takes up space. And Winnie, where did you get that definition?
The model.
And where did you get that definition from?
The book.
Was it in our video yesterday? Okay. So we should already have those two from yesterday. Okay. Today we're going to be using a scale. We're going to be using graduated cylinders. We're going to be using beads. We're going to be using sand. When we read down through our lab sheet here, as a scientist, it's super important that you read every step carefully and that you follow the directions specifically. If you were in your own groups doing this, if you mess up the process, you tend to not get good results. Okay? And if we were doing this in small groups, paired up, we would take a look at all of our results collectively, and we could draw a lot of conclusions based on our collective results. All right? This is a controlled experiment because I'm doing it, and because I'm doing it, and I understand the experiment, and I've done the experiment several times, there probably won't be too many mess-ups. Does that make sense?
Yeah.
Okay? If you were doing it, you don't have the experience that I do with labs, there is a larger possibility of mistakes, and our results would not be as pure or as good. Does that make sense? Okay? So, when we do experiments, you need to usually do several experiments and see what your results are, because you can have what are called outliers. So let's say that we did 10 experiments of the same thing, and one of our results was way different than all of our other results. Then probably something horribly went wrong with that one time that we did it. Okay? So we probably would want to throw those results out, that outlier. Does that make sense?
Yeah.
Okay? Because it probably something we did wrong. It would be like baking a cake, and we baked the cake 10 times, and one time it didn't turn out right. Well, maybe we forgot to put eggs in. Maybe we mismeasured the water or the milk or whatever we used. Okay? But it only happened that one time. We thought we were reading the directions correctly, but somehow we didn't that one time. Okay? So when you have an outlier, typically you want to discount that outlier or figure out why maybe it went wrong. But you don't just want to do your experiment once and say, oh, those are our results. Okay? we're all only going to do our experiment once, but I can assure you that our results, because I've done the experiment several different times, I've watched students do it several times, that our results are going to be pretty accurate because I have the experience of seeing the results several times. Does that make sense? Okay? But typically as a scientist, you don't just want to do it once or twice. All right? So let's take a look at what we will be doing. All right? If you were doing this experiment, let's see, I think we were not given one. Okay, it says to put the bag on the scale and set the scale to 0. What that is telling us is that we want to take the weight of the bag out of the picture. Does that make sense? Okay. So when I put the bag on the scale, I set it to 0. All right. So now it's only going to be measuring what's in the bag. Does that make sense? Okay. So I've zeroed out the scales. Fill the graduated cylinder with 25 milliliters of beads and record the volume on the chart. Okay? So when you look down below, we will have a chart that we're going to be filling out. All right? Okay? Then we're going to put the beads in the bag and measure the mass. Okay, I'm using a scale for that. We're going to record it. We're going to pour the beads into the cup. I'll pour the beads into the cup. All right? Then we're going to fill the graduated cylinder with 25 milliliters of sand and record the volume on our chart. Then we're going to put the sand in the bag and measure the mass and record. We're going to pour the beads back in the bag with the sand and mix it up. We're going to fill the graduated cylinder with a mixture of the beads and the sand and record the volume on the chart. Then we're going to measure the mass of the mixture of beads and the sand and record. Okay? So we're going to do it separately, the two volumes separately, the two masses separately. The masses would be on the scale, right? Then we're going to combine them. We will see how much volume it has, and then we will see the mass of it by putting it on the scale. All right? So, at this moment, you are going to make a prediction. Okay? Now let me explain it so that you understand what you're answering here. Will the combined volume be the same as adding the two separate volumes? In other words, when they are mixed together, when they are mixed together, when they're mixed together in one baggie, okay, and poured into a cylinder, okay, will that volume be the same as just adding the sand volume plus the bead volume? Okay? Yes or no, and explain your reasoning. All right? Now stop. Don't start that yet, because I'm going to explain the next one, so that I can give you time to write on both. Okay? The second part is, will the combined mass be the same as adding the two separate weights? Okay? In other words, right here, combine, mix together, be the same. So when they're all mixed together, right? Will it be the same as adding the sand mass plus the bead mass separately? And explain your reasoning. What do you think will happen? Does that make sense? Someone out there?
Yeah.
Okay, so in other words, for the mass, if I take two baggies, I have sand in one, look up here please, sand in one, beads in the other. I measure, I do an addition problem. If this is 2 and this is 3, it would be 5, right?
Yeah.
Okay? If I pour them all in one, and I measure, the question is, will this be 5, yes or no, and why? Does that make sense?
Yeah.
Okay? Start writing for those two. This is your prediction. And you're explaining your reasoning. Not just because I think so. You're trying to convince somebody. Go. Start writing.
Those of you at home, you do your writing. When we get done with this experiment today, you will be submitting those papers to me.
Remember, you're doing both of them. Take another minute to finish your prediction. Please finish up your prediction. Okay, all predictions are done before you do the experiment. If prediction is not, I've seen the experiment and now I write down my results. Okay, and we talked about prediction before we even got started. Okay, what do you think is going to happen and why? All right. So now I'm going to do the experiment for you. Again, in years past, you've all done the experiment, but rules have changed. Okay, but quite honestly, we'll get better results this way because I'm controlling the experiment and I know I'm doing it right as opposed to what's happened in the past. Some students didn't follow the directions, so therefore the experiments created false results. Does that make sense?
Yeah.
Okay, so here we go. I've already measured the bag and zeroed out the scales. All right? The next thing I'm going to do is fill the graduated cylinder with 25 milliliters of beads. Okay? So I'm doing it over the tray, so if any beads spill, they spill on there. And right there is about 40, so I have too many. So I just pour them back in. The ones I don't need, I didn't pour enough back, that's for sure. I poured too many. And right there is right at 25. I'm going to bring it around for a couple of you to definitely give me that 25. Do you see that?
You do the magic trick.
Get a couple more of you to witness the 25. Yes? Okay. All right. So next, I am to pour the beads into the. Oh wait, I'm to record the volume on the chart. On the chart, the volume of the beads is 25 milliliters. So I'm recording. And scientists keeping accurate record of their data is important. Yes.
What did I call it?
And then I am putting the beads in the baggie. I'm sealing up the baggie so I don't lose my beads. Okay? And I'm putting them on the scale and I'm getting a mass of 10 3/10. Okay? No, not 10 pounds. 10 3/10 grams. Okay? 3 grams. 10 3/10. Okay?
This is kind of math.
All right?
Yeah, I know.
All science and math are very much related. As I once told a science teacher friend of mine, science could never live without math. Math could live without science, but science could never live without math.
It can't, because you gotta do math.
Okay? So next, Next, it says fill the graduated cylinder with 25 milliliters of sand. Okay. So again, I'm making sure I'm doing it over the tray so that if it spills, we've contained our mess. I think I'm very close. I'm at 24.
Then it takes a lot more to be.
Okay, I'm at 25. Well, a couple others of you see that I'm at 25.
Yep.
Add over. So you like, you do like, you like, add over. This is all good.
Okay. So up here, I need to record my volume of my sand is 25 milliliters. I pour the sand
Into the baggie.
into this baggie.
Oh. Is it way more?
Okay. And its mass is 37 and 5/10. Okay. Now, at this point, when I look at my table here, this says beads plus sand. 25 plus 25 is 50. I need to add the masses together. 0 and 7.
47.
1 and 3. Okay. And all of these should have a label of grams. So I didn't do that. There we go. So here was adding them separately. Do we understand that? Adding them separately. Okay, we've not combined them yet. That combining them is mixed. Does that make sense?
Yeah.
That is mixed. Okay? So now we need to mix them. And I will pour my beads and sand together in the same baggie. Seal it up. Mix them. Now, out of curiosity, before I do anything else, how many of you said the mass would be the same? The mass would be the same. A couple of you did. All right. Anybody from home say the mass would be the same?
I said the mass would also be.
Anybody at home say the mass would be the same? Hand up. You did? Okay, a couple of you. All right. Because I already have them in the baggie, I'm going to do the mass first, and we'll do the volume last. And there we go. We have it at 47 and 18. Okay.
Right.
All right. And now,
look at this and it's at least 12%.
Okay. So, I have my mixture now. And I'm going to pour it into the graduated cylinder.
The bees, all the bees go first. Wait,
And the question is, will it be 50, right? And it is, what's that? 37 or 38, we'll call it 38.
how did it? 25 plus 25 is 50.
Okay. All right. So,
Sure.
it was at 38 milliliters. Okay.
No, if we put
So, from here on out, you would need to answer the question, were the volumes the same? Were the masses the same, right? Okay. Did the total volume or mass change after the mixing? One or the other? Right? Now, when it says explain, you're not explaining, well, one was higher than the other, whatever. Why do you think that happened? Why do you think that happened? That's what you're explaining, okay? So you're explaining why. Why do you think that happened? Okay? And then what did you learn about mass from this? And what did you learn about volume from this? This is volume, remember? How much space it took up? Right? This is space. Okay? All right? And this we weighed on the scales, right? We use the scales for that, right? Okay? All right? That is due tomorrow. Okay? Everybody hear that?
Yeah.
All right. Now, I will be sending you a read work article, right? You know what that is, right?
Yeah.
Okay? It is worth 10 points. It is worth 10 points. Today is Tuesday. It is due by Thursday. Those of you at home need to have it submitted to me by Thursday as well. I did not put it in Google Classroom yet because I didn't want you getting all excited about what to do with it. I will be putting it in there now. Those of you who don't have me for science should be looking in your science classrooms for it. Your teachers may have already put it in there. Any questions from home? I will see you guys tomorrow as we continue on with this lesson. This is due tomorrow. Okay? You may finish it up now. If you finish it now, you may give it to me now. Those of you at home, as soon as you finish it, you may submit it to me. You can submit it to your classroom teachers. If you don't have me for science, you submit it to them. But if you have me for science, you submit it to me. Questions from home? All right. So go ahead and finish up on that while I'm sending you the read word.